So ladies and gentlemen, everyone else out there, so we're now into our final session before lunch, and I'd like to welcome Jonathan Kryzosiak. He's the External Hazards Topic Lead for Sizewell C, running his organization, Tech Limited. And today, we're quite fortunate for him to be here, because he'll be talking to us about the management of climate change risk in the nuclear industry and wider society. Obviously a burning topic to be discussed. I'll hand you over.
Real, thank you very much. So yes, really appreciate being here and having this opportunity to talk about climate change risk. So I will just dive straight into it. So I want to start with a quote. I really like this quote in general, but in terms of climate change, I think it is also quite apt. If you fail to plan, you are planning to fail. And in terms of climate change, we know from the IPCC's latest reports that the climate is changing and it is our fault. So we need to do something about it. And what's generally accepted is we need to mitigate climate change, we need to reduce our greenhouse gas emissions, but we also need to adapt to climate change and adapt to the way the climate is going to change going forward. So both of these things are massively important for humanity in general, for ourselves, our jobs, our businesses, our friends and our family, our homes. We need to do these two things, mitigate and adapt to climate change. But in the midst of all that, there is also an opportunity, which I'll come on to. But just briefly, something about myself. So yeah, I'm Johnny Kryzosiak. I've worked in the nuclear new build industry. Mainly new build, but a bit in the operational side of things as well, mostly in Hinkley Point C and Sizewell C in the UK and in France. My background is around safety and hazards, particularly natural hazards, and that's where the climate change comes into it. So what I'm going to talk to you today is about the climate change science and the implications of that to the nuclear industry and some of the implications for a wider society as well. So the first thing, I think this is key, is that net zero does not mean no climate change. Net zero is massively important. It is hugely important. We need to achieve it to avoid the catastrophic effects of climate change. But the climate is still going to change, and we have to adapt to that. So we've got a couple of graphs from the IPCC to help explain that. So unfortunately, I can't point to things, so I'm just going to have to describe. So on the left-hand side, you've got two graphs showing CO2 emissions in the top left and CO2 concentrations in the bottom left. And that's over the next 1,000 years for 4 different scenarios. So these scenarios are basically theoretical amounts of greenhouse gas emissions, in this case CO2, theoretical amounts they could be emitted, the rates that they could be emitted by over a future time period. And these are then plugged into global climate models to understand what the impacts of that would be on the climate change, on the climate. So if you look at the top left graph and the red line, this is the scenario RCP 8.5, what you can see is that emissions in this scenario, they go up and then they go back down again. But over the same time period, in the graph below, and in CO2 concentrations, they just go up. And they stay up to a high level. Essentially, once CO2 is in the atmosphere, it takes a very long time for it to decay away or to be absorbed as part of the rest of the carbon cycle. So what you've got is that when you reach this net zero point, so when that red line gets kind of to the 0 points on the top left graph, you don't have an instant climate reset. You've got this lag effect between CO2 emissions and CO2 concentrations. So the way I think of this, we've had the Earth in the Holocene period going in equilibrium for quite a while, and then we started to emit. We've increased greenhouse gas concentrations. We've then have higher levels of heat being absorbed within the climate. So I think of this as a snow globe is my kind of analogy to this. You have a snow globe on the table, it's in equilibrium. You pick it up, you start to shake it, you start adding energy into that system, and if you look inside the snow globe, you've got turmoil. When you put it back down on the table, even though you're no longer shaking it, you're no longer adding energy, inside there's still chaos and there's still turmoil. And that's the same with the climate system. So on the right-hand side graph, you can see this is surface air temperature on a global level over the same 1,000-year period. You can see at the points where you've got the net zero, this start to dip, you can see that even though we've reached net zero at that point, in terms of the effects on the climate, we've still got the air temperature remaining high. There's not this reset. So what this means is that reaching net zero doesn't mean you're going to instantly reset the climate. You've got to, well, essentially reaching net zero is massively important as quickly as possible because this keeps concentrations low, so minimizes the amount of change. But we've got locked in climate change, and we're going to have to deal with that. So I think that's it for that slide. Yeah, so the climate change is not if, it's when, and it is how much. And that's kind of one of the key points. So the question then becomes, well, what level of climate change is going to happen? How do we deal with that? So to help with that, we've got scenarios. So these scenarios, the ones on this graph here show representative concentration pathways. And essentially, as I said, they're theoretical amounts of how much we will, as humanity, emit over the next 100 years. And they are used to then feed into climate models, which provide projections on how the climate will change. And the RCP scenario is massively useful in the UK because they've been fed into a set of data by the Met Office called the UK CP18, and this provides really useful localized, regionalized information to be used in hazard assessments for the UK, but also for, well, any industry, nuclear or otherwise. But you can see there's a big range in how much we could emit, and that's because the politics are uncertain. So there's a lot of uncertainty around how the climate will change as you go forwards. So just a quick point on the uncertainties. So there are different types of uncertainty in projections. This graph kind of explains that. The green is emissions uncertainties, the blue is modeling uncertainties, and the yellow in this graph, which shows global average temperature of up to 2100, the yellow is the natural variability in the climate. So what you can see is that actually after 2050, that's when the emissions uncertainty begins to dominate. Prior to that, it's these other uncertainties which dominate. So this is useful from a kind of planning perspective and from the industry to understand, because depending on the planning horizon of what you're doing, you need to a greater or lesser degree, consider the amount of emissions. If your planning horizon is just the next 10 years, then the emissions become less dominant in terms of the uncertainty. So it's a less important factor. So it's a useful thing to understand from a kind of planning perspective. So, key points: climate change projections show the range of possible futures. Yeah, we've got we know there's going to be uncertainty, and the projections help provide kind of an understanding of what the climate will do under different types of emissions. And the further you look into the future, the greater this uncertainty is. So next, so this is a great slide. I love this. I've stolen it from the Climate Action Tracker. So before I go into kind of the nuclear implications of things, I just want to talk about Paris Climate Agreement and the kind of the goals, the global average temperature goals of 1.5 degrees and 2 degrees. So what this figure shows is that you can see in the middle of it, I wish I could point out where I'm looking, but we are currently at 1.2 degrees warming compared to pre-industrial levels, or we were in 2020. We see the goal of 1.5 degrees, but actually what this group Climate Action Tracker does, they look at the pledges. So what they look at the governments, and they see how much the governments have said they want to reduce emissions by, and they analyze that in the set of models to see what that would result in terms of future heating. So in terms of pledges, we're at 2.5 degrees, but in terms of policies, so things that governments have actually implemented, we're actually around 3 degrees. So when people talk about Paris and 1.5 degrees, 2 degrees, it's important to remember that's just targets. In terms of policies, we're not there yet. We're still at around 2.5 degrees. And in terms of actual policies, we are even further away. We're actually at around 3 degrees warming. And so it's these numbers, it's worth just keeping that in mind when you hear about climate, the 1.5 degrees. But the other fact that's important in regards to these is that they are global averages. These numbers, they don't represent the regional or local effects of climate change, and they can be much more dominant. They also don't represent extremes, which I'm just going to have a quick mention of. So this graph here shows for different global warming levels above pre-industrial levels, how extreme high temperature events would change. So if you look along the bottom, along the x-axis, you've got, we'll just look at the 3 degrees increase, because that's where our current policies are as a globally. We're actually on target, we're on track for a 3-degree increase. In terms of a 10-year or 50-year higher temperature event, the intensity of that increase in that rare event is actually around 4 degrees. And you can see that the uncertainty range increases and the best estimate increases as the return period increases. So for the nuclear industry, when we've got to think of 10,000-year events, these heat wave events become actually quite extreme, even in a 3-degree world. And this is still a global scale, so it's still not taking into account regional or local effects. So, for example, London, where heat waves are already quite unpleasant, we know, depending on how far you look in the future and the various scenarios, heat waves in London could be 3, 4, 5, 6, 7, 8 degrees hotter than they currently are. So, yeah, when you hear about 1.5 degrees, 2 degrees, there's a lot more going on behind all of that. Right, yeah, so extremes, I've talked about how they could be different in terms of severity. So in the top graphic explains that. You can see hazards could be more severe, more intense, but you could also get them becoming more frequent. So you could have more frequent rainfall events, as we've seen this in the last kind of 12 months. The duration of extreme events could change. They could be longer or they could be shorter. You could have seasonal shifts in that, for example, the monsoon could arrive earlier or later. And if you think how much agriculture is based off the monsoons, then you can see why that would have a big impact. And you can have changes in speed of the onset of a hazard or the spatial extent. So, for example, flooding, if you've got more severe events, it's going to cover a wider area. So the key point here is that increases in global average temperature don't tell the full story. When you hear of 1.5 degrees, 2 degrees, which we're not actually on track to reach yet, they don't sound that bad, but the reality is behind that, regional local effects, extreme events, that in those 1.5, 2 degree worlds, those regional localized effects really make a big difference in terms of extreme events, and that could have a huge impact on society as a whole or industry. So some other kind of key messages so far. Reaching net zero as soon as possible is key. The sooner we reach it, the lower the concentrations of CO2 and greenhouse gases will be in the atmosphere, and that minimizes the amount the climate will change. But the climate is still going to change, regardless of when we reach net zero, because there's a lag effect between these two things. How much it changes remains uncertain, because we don't know how much we're going to emit. And if you're interested in extreme events, which we are from the nuclear industry, then you can't just look backwards at past events anymore. You need to look at these projections and factor that in as well. So what does this mean for the nuclear industry? So, I mentioned in the last 12 months, we've had rain, we've had flooding in Germany, in China, in London, New York. We've had heat waves in North America, Greece. We've had wildfires. There's a growing recognition that the climate is changing, and it will continue to change. And this needs to be, we as nuclear professionals need to incorporate that into how we manage risk and safety in the industry. So how do we do that? There's some, well, look at regulation, and RGP is always a good place to start. So the SAPs, the ONR SAPs, they have a concept in there which is really, I'm going to come back to, around reasonably foreseeable and reasonably foreseeable climate change. So it's a useful thing there. The external hazards tag has some great information, especially in some of the supporting annexes. If you're interested in this, there's some really good stuff there about what the implications of climate change will be. There's also some UK CP18 joint regulator position statements, which has information around how you should use this Met Office data UKCP 18. And there's a few other kind of links there which I unfortunately don't have time to go into. So I'll continue onwards. So for one of these things I mentioned, reasonably foreseeable climate change. For Sizewell C, how do we do that? So we think of the scenario, or we consider the scenario RCP 8.5. And we do that because it is the most severe scenario within that data set. And by considering that level of severity, and we assume that the climate will change by that much, and that means we can build that into our assessments and build that into our design such that we end up being robust to that level of climate change. There are other ways you could approach reasonably foreseeable, but in terms of the external hazard safety case, that's how we've done it. There are other parts of the safety case which are also impacted, but the kind of bit I'm responsible for, that's what we do. There's another thing as well, which so within some of the regulation RGP, there's something called managed adaptation. And this is a really useful concept in that the idea of it is that you build in the design now the ability to adapt it later if required by extreme higher levels of climate change. And you can see the kind of why that would be useful if you look at global sea level rise. So what this graph shows is sea level rise under various scenarios up to 2100. There's quite a lot of uncertainty around this. So what you can do is design, if you need coastal flooding protection, you can design it for a lower level. So SSP 1, for example, that dark blue line. But you could also design in the ability to adapt later by having more robust, meaty foundations, such that you can build on that wall and make it higher, so that if the sea level does rise higher than you've expected, you can still remain protected. So this, managed adaptation is a really useful concept, and there's some very powerful ISO and British standards which help with that. So ISO 14090. This could be used by any organisation. I'll come back to it in a little bit. And a British standard 8631, which is a really useful way of looking at how you could adapt to climate change and plotting your path between those different options as the severity of climate change passes certain thresholds. So there's a couple of really useful standards there. Right. So I've talked about nuclear and the nuclear implications the climate change implications on nuclear. I just want to touch on the wider economy as well. So I've talked about the physical effects, so changes in extreme events and weather, but there are also going to be transition risks associated with climate change. And these are things which are associated with the move to a net zero economy. So there'll be changes in technology, there'll be risks to a business's reputation, there'll be changes in markets, and there's going to be changes in policy and legal, policy and legal requirements organizations have to deal with. So there's this growing recognition that essentially the worldwide economy is at risk from climate change, from these physical and transition risks, and there isn't a great understanding of which organizations are at risk. So there's a demand, or an increasing demand, for organizations to disclose and report on their exposure to climate change risks. So there's a lot of work being done by something called the Task Force of Climate-Related Financial Disclosures, which I won't go into, but essentially they came up with 11 recommendations which around what organizations should disclose and report on, such that stakeholders of that organization, whether it's an insurer, a creditor, a regulator, or a shareholder, so those recommendations in this disclosure will help those stakeholders understand that organization's exposure to climate change risk. So the Financial Conduct Authority, actually they've taken those 11 recommendations and they've made it obligatory for large premium listed companies in the UK to disclose in regards to TCFD recommendations. And there's an increasing drive, or there's a plan for those recommendations to be, or for organizations to disclose in line with those recommendations for a wider set of organizations within the UK. So I don't have time to go into the IFRS stuff, so I'll just continue on. But the key theme is that stakeholders in organizations want to have a better understanding of those organizations' climate change risk exposure. And to do that, an organization has to understand its risk exposure. So it comes back to these standards again, these useful tools. So this BS 8631, one of the key concepts in it is adaptive capacity. That's the organization's ability to adapt. How well do they understand their climate change risks, and how well are they building it into their normal business kind of decision making and processes and that type of thing. And to help with that, that's what this ISO 14090 is massively powerful. It can be used by any organization. It's not specific to nuclear. It can be any organization, whether it's a regulator, an insurer, or whether it's a high hazard industry. And it enables that organization to systematically look through their business and consider climate change risks, and then build that climate change risk management into their normal business practices, such that they can have actions and priorities in regards to climate change risk. So this is a massively useful standard, which I think a lot of organizations could benefit from using. There are some other ones as well. So ISO 14090 sits at the head of a family of standards. 9.1 is more detailed on the risk assessment. 9.2 is around local governments and communities. 9.7 is around actual financiers and how they can use their influence as a stakeholder to change what governments what their stakeholders do. Right. So coming to an end. So we know the climate is changing. We know that, and quite often there's a lot of doom and gloom messaging. But the reality is, or in my opinion, I think there is a lot of I see things differently. I think there is, and it comes back to that quote at the beginning. We can plan, so therefore we can avoid failure. And this means that the organisations need to understand their impact on the climate and the climate's impact on them. And we've got the tools, we've got the methods and the know-how, these standards, and the people who use them. We've got they exist to be used. And that will help essentially raise awareness of climate change risks. And raising awareness is the kind of first step in bringing about change. So for me, this is a kind of positive thing that can be done, because we know there's a problem, we can do something about it, we've got these standards, and we can apply them, and we can bring about actual useful change. So just some key points there. I think one of the main ones was net zero. Doesn't mean no climate change. I covered that at the beginning. There's the global average temperatures. They don't accurately express the real risks associated with climate change. In the nuclear industry, we need to talk about reasonably foreseeable climate change and managed adaptation are really useful. More widely, in the wider economy, organizational stakeholders have a greater interest in organizations' climate change risk exposure and the need to disclose. And to get around that, they need to have better, for organizations to do that, they need to apply the tools and methods which exist. And by doing that, they'll raise awareness, and raising awareness, the first thing that is required to bring about actual change. So there we go. I apologize, it was a bit very rapid, but thank you very much, and I'm looking forward to any questions there may be.
That's brilliant. Thank you very much, Johnny. Much appreciated that. It's good to see that there's so many standards out there now that have evolved over the years. Because at one time there was hardly any. I'd say go back probably about a decade ago, there hardly were any standards out there to go on. So it's pleasing to see that those are coming on.
I think there's been a lot of work recently. I sit on the British Standards Adaptation to Climate Change Committee, and there's been a lot of work within that, and ISO generally to develop these standards and actually make it more useful for organisations.
Okay, just a few quick questions, and there are quite a few coming in on the line. So one is from, I would say, a climate change denier, dare I say.
Right.
And I can see where they're coming from, is that if we try to build in climate change into our designs from T0, will we effectively price out the development of new nuclear power? And let's face it, we need power now to decarbonise our grid system. not in 100 years' time.
I mean, it's a good point. I don't disagree. We need to get new build going. And that's why managed adaptivity is a really good tool in that we've got to use, because essentially you think about how it could change now, and you build in the ability to change later by monitoring thresholds and then adapting the design if required. So you don't have to build to the most extreme levels of climate change right now. There are other ways, and there's best practice methods for doing that. So it isn't a blocker, in my opinion. It's actually an enabler to give confidence to the regulator and society that we're really considering the risk, and building in our ability to deal with it.
Okay, so the opposite is, well, the COP26 message is loud and clear. The government's announced by 2035 that we need to decarbonize our electricity system. That's a good target. Whether we meet it, it's another thing altogether. But is that having what one would say a negative impact on resilience, adaptation, in terms of our corners being cut in the industry, dare I say?
Well, corners are definitely not being cut in the industry. That's definite. For Sizewell, I mean, I know the other industries, other parts of the nuclear as well. I mean, they are aware of this risk, and they really consider it in what they're doing, and it's important that they do. So definitely no corners are being cut, but there is a definite focus on mitigation, so reducing greenhouse gas emissions, and there is less of a focus on adaptation right now, and I think in my mind, there needs to be a focus on both, and it's important that there is that focus on both, because the climate will change, and we need to build in that resilience. But I completely understand that, potentially the more pressing thing in everyone's mind is lowering greenhouse gas emissions, but it mustn't be forgotten that the climate will change, and we have to survive those changes too.
Sure. And final thought, rather keeping people away from their lunch, we're all a bit hungry. Question is, or a thought is, we use the language reasonable, we use the language severe at the same time, robust. Now, one could argue that someone's reasonableness is another person's unreasonableness. So on one stage we talk about RCP 8.5, but you're taking the severest consequence. That doesn't sound reasonable to me in that context.
There was a lot of discussions around why our approach is what it was. It's a complex problem, and language is difficult. So I mean, we do have to consider where expectation is reasonably foreseeable. How you define that, becomes very very important. But you don't want to not be robust, and I think that's the key thing. So being conservative by assuming a large severity of climate change increases your resilience and your robustness. So it's a conservative approach is to consider more climate change. But is that actually a good way of defining reasonable? I'm not sure, but it's I think from a safety and a nuclear from a nuclear professionalism perspective, I think conservatism and building in resilience and robustness is definitely key.
Always sounds good.
Yep.
Thank you very much for your time, Johnny. It's sparked a lot of interest, the discussion has, and fits in very nicely with the morning session, which we shall now conclude.